Hi everyone, so here's kind of the second video just to help go over Excel a little bit more. So all you'll do is you'll kind of fill out this template when I attach it to Canvas and email that to me. Since we weren't able to do this lab, all I really ask is that you kind of use Excel to work through the data analysis and determine the activation energy of the catalyzed and uncatalyzed reaction, since we kind of went over in the last video how to determine the rates and rate law. Okay, so this would be the data table that you'll get. You have your concentrations of your iodide and your diproxy sulfate and the temperatures and time. So again, notice how the first 5 runs have the same temperatures because those were the runs used to find the rate law, and both of these are first order. And then you have the next 3, which are the uncatalyzed, and then the following, which are the catalyzed. So you have all this data, you were able to take the time and then calculate the rate. So knowing that you have the rate and you know each concentration and you know its first order, I want you to calculate the rate constant using Excel. Well, the way that you can do that is you press equal and then parentheses. Well, if a rate is equal to constant times concentration, constant is equal to the rate. Actually, let's take away the parentheses first. So you take the rate divided by parentheses, both concentrations multiplied together. Enter. So notice here again, when you press equal, I said the rate divided by, and then I put in parentheses my 2 reactants being multiplied together. I didn't have to add any exponents because they're both first order. And then what you can do is you can kind of double click and check that clicking into the box, it calculated the appropriate values. So here's your rate constant. Cool. Well, in order to find your activation energy, you have to plot the natural log of the rate constant and the inverse temperature in Kelvin. Well, you're given your temperature here in degrees. So then what I want you to do in the second column is convert that to Kelvin. Now, the reason I'm going through this in detail is to kind of show you as you move on in chemistry how to use Excel to avoid a long time of doing different hand calculations. So you press on the little box up here again, you press equal. Then the temperature, 20 degrees. Well, how do you make 20 degrees Celsius into Kelvin? Plus 273.15. Enter. Awesome. And then again, if you click down, whoopsies, you can either double click or you can drag down and you can check, you get the appropriate temperature plus 273.5 Kelvin to convert. Awesome. Now you have your rate constant and you have your temperature. Do you have enough information and the way you want them to be to actually solve for your activation energy? No, because you need it to be the inverse of the temperature and you need it to be natural log. So then again, using Excel, instead of going through 14 different calculations, you press equal 1 because you're taking the inverse divided by the temperature of Kelvin. And then you can double click and you have all of that data ready for you. All right, last one here, natural log of K. Well, the natural log will be equal to ln, there should be a function, parentheses, the number. So the rate constant, close parentheses, equal. And then you double click and you should get all those values. So now you have all the values that you need and you want to plot. Now again, you have to split this data into 2 graphs. Now the first 5 runs were to determine your rate law. You did not change the temperature, so you are not using that data to find the activation energy. Then from 6 to 9, that's when you change the temperature to find your activation energy of the uncatalyzed reaction. So you use the run 6 to run 9, these data from 1 over temperature natural log of Kelvin to plot, and then from 10 to 14. All right, so how are we going to do that? Well, you can say, I'm going to make a scatter and again, I'm doing this a couple of ways. There's always different ways to do this. And you can format your chart area. Actually, you double click on your chart and you do select data. And you kind of highlight from where it's coming from. Well, it's going to be from 6 to around 9. And then you get a little bit more specific. Well, your x values, it's the natural log versus the inverse Kelvin. So inverse Kelvin, I go from here to 6, that's right here, down to 6, 7, 8, 9, enter. And then my y values. My y values will be the natural log of Kelvin. Boom, 6, 7, 8, 9, enter. Okay. Alrighty, so then what you can do from here then is, I'm not going to walk you through everything because we've done kind of practices of this already. But what I want you to do is I want you to make sure that you are formatting it correctly, as in your chart title, your axis title. And what's super important is to find the activation energy. So therefore, you need your linear trend line. Well, you click on trend line, you can double click, make sure it's linear, go to options, display equation on chart. Then you see what your slope is. Now from here, you should be able to solve for the activation energy of the uncatalyzed reaction, and you do the same exact process for the catalyzed one as well. Making sure you label which graph is which, writing the name as the title of this Excel file, and then turning it in that way. And then that's all really you would have done for this entire lab, is getting the data for the concentrations and the rate, and then using that from the different temperatures to find the rate constant, making the units the way that you want them using Excel because it's a faster way than hand calculating it, plotting, and finding the activation energy.